This class I actually have. All right, so so for completing the square, we need to talk about our perfect square trinomial. Again, our perfect square trinomial comes from squaring a binomial. So if I start off with just two letters, A and B, it doesn't matter if you're adding or subtracting them. So it's one or the other. All right. If you square it, it'll give you a trinomial. If it was addition, then you'd end up with a squared plus 2ab plus b squared. If it was subtraction, that would be the sign that gets affected. All right. So again, this has a direct correlation to this. If that's plus, this is plus. If that's minus, this is minus. All right. So, you guys familiar with your perfect square trinomial? This look familiar at least? No? All right. So let's go back one step further. All right. Are you guys familiar with a quadratic in standard form? No? All right. So ax squared. Now I'm not writing this part on my notes. This is just separate. Ax squared plus bx plus c. This is a quadratic in standard form. And that square just does what? Alright. Now, guys, listen. So again, this is a quadratic in standard form. Normally, in standard form, you have a coefficient with each of your x values. You have an x squared, because it's quadratic, right? You have an x, and you have a constant. Now, most of what we're going to be dealing with are similar to this. We're going to have some type of trinomial with a variable that's squared, a regular variable, and some type of constant. All right. So, what we have to do is we have to change it so that we are dealing with a perfect square. Not all trinomials are automatically perfect squares, but we want to make it a perfect square. So we're going to be given this as an equation. Back in Algebra 1, what you do with these is you change it into a perfect square so that you can solve. So there's many different ways to solve a quadratic equation. You could solve by factoring, you could solve by graphing, you could solve by using the quadratic formula, or you could solve by completing the square. So there's 4 different common methods. We're using completing the square not actually for solving, but for rewriting an equation. All right. Now, all right. So when are we actually going to use completing the square, or how do we complete the square? So again, this is just a basic concept that you should be familiar with. Now I'm going to go over the steps on how to complete a square. And in your Springboard book, they actually list out some good steps for completing the square. So if you want to take a look at page 396, you could look at this as we do this next part, because your Springboard book lists out the steps as words. It actually writes everything out in words. So I'm not going to repeat what your book already does for you. I'm going to do this as an equation. All right? So you can either reference your book, which has all the steps there in words, or you can reference what I'm going to do, which is written out step by step in equation format. So you will be given an equation that looks something like this. X squared plus bx plus, it could either be plus or minus actually in both of these spots. So I'm going to say plus or minus c equal to d. Now, the only thing that will actually be a variable when you do one of these problems is the x. All right? The A, B, C, and D here.
I don't know who put it there. I just about to see.
Oh. Who did I just send to the bathroom?
No, I found it in the bathroom.
Yeah, I know. I just sent somebody out. Yeah. I don't know. They might still be in the bathroom. Who knows?
It was Jaden.
Oh, okay.
AJ was looking for it.
All right.
So the plus or minus, say for the first one you can say minus and the next one you can say plus.
So no. So like there's a direct correlation here. So like if this is plus, this sign is plus. If this is minus, this is minus. All right. I'm just writing it out as as an equation so that you can see how the signs relate. All right. We'll do a few examples. All right. Now, and on here, so it doesn't matter if this is plus or minus. Again, I'm trying to show it to you so that you have it either way. Now, the first step in completing the square, you'll notice on here, we don't have an a value. And that's for a reason. Nothing that we're doing in this class this year will require us to have an a value. All right. Now, in Algebra 2, you'll probably have a values. If you had a value out here in front, your first step when completing the square is to get rid of it by dividing it off. All right. Yeah. So there are a couple different methods, but we're going to say if you had an a value, you would divide it off. So you divide everything by a, and that way it just go away. And it makes completing the square a lot easier if you don't have an a value. So for everything in here, we don't even have to worry about the a. That's why I wrote this without even having the a out in front. So the first step in your book actually says take the constant value, which in this case would be your c value, and remove it from the left side of your equation. A lot of the equations that we get won't even start with having a constant over there. It'll just have the one on the right side, which also makes it easier. But again, if you have something over here, first step is to get rid of it. So this part stays the same. X squared, your sign here would stay the same. But now, the c would go to the other side. Now, I'm going to leave a space. I'm leaving a space on purpose. This c would now be on the other side. But what's going to happen to our signs? It's going to switch. Because if it was addition, to get it over, you'd have to subtract. If it was subtraction, then you'd have to do addition. So, again, it's going to end up being the opposite. Next. All right. So now I'm going to do the same exact thing again. Again, I'm leaving a space on purpose. There's a value that we are missing that we're going to plug in for in this next step. So, in order to actually complete the square, we need a perfect square trinomial. Yes. So, the part that we are missing here is the b value divided by 2 and then squared. So, we're going to add on, and it's only going to be a plus sign, b divided by 2 squared. That same thing has to also be done on the right side. Because anytime you're doing anything with an equation, if you add something to one side, you have to add it to the other. You have to balance the equation. So this also goes to the other side. So we're going to add it. Now, we're really done with this side of our equation. This side, again, notice, all the values that are over here, are there any x values? No. All this side is numbers. So each one of these represents a number, a numerical value. So as you go through, I know this side looks confusing right now. But that side will all simplify out because every single one of those will be a numerical value, and you're just going to have a whole number over there. So that's the easy part. Now, over here on this side, this part is where we're going to change it back to a binomial. So we just this part is actually where we completed the square. But now we need to rewrite that perfect square trinomial as a binomial. So what we're going to do, all right, do a set of parentheses, put square there. There's a set pattern here. And you can look at this one of two ways. All right. It's the first term square rooted. So x squared square rooted would be x. The last term square rooted, which we had b over 2 squared. So it's just going to be b over 2. And then the sign from the middle. So if it was positive, it'd be positive. If it was negative, it'd be negative. But that's the pattern every single time. You square root the first term, you square root the last term, you take the sign from the middle. If you have a perfect square trinomial, again, that will always be the pattern. All right, you had your hand first.
Yeah. So we're always going to have to add in the b divided by 2 squared, but that's going to be...
No, we're always going to have to add that part because that is the actual part that's called completing the square. By doing that, we made this a perfect square trinomial.
And the b is always going to be given to us, right? It's going to be a number.
The b will always be a numerical value, yes. Yes. Is it cut off? Or you just can't see the bottom? Okay, sorry. Yep. Now, okay, we're going to do this with a couple different sets of numbers. So first, I'm going to give you an example of something that you would have had last year if you had done this last year. So some of you guys have done this probably before. Some of you guys probably haven't. All right. You will see this a lot more in Algebra 2 because you'll definitely cover completing the square in Algebra 2. It's, I think, in the first half of the year. BX. So it's still, again, this is a perfect square trinomial, right? So there's a pattern. So let me show the top again real fast. So up here at the top, there's a pattern, all right? Notice we have a binomial, here we have a trinomial, right? If we went backwards, you could ask the same question. What happened to AB, right? But that value is made from squaring both of these, all right? So you can look at it as, see this first term? That was that first term squared. This last term is the last term squared. The one in the middle is the two values multiplied together times 2. In this format, now, A and B up there don't directly correspond to A and B down here, all right? So don't get that confused. But A is kind of like your X value. B down here is not directly correlated to B up there, all right? So half of this would be that back value, but squared. So on here, you can either look at it as how I told you, take the square root of this. You could also say that this could come from the middle term and just do half of it. That also works. Yes? Water, you said? Yeah. Here's the pass.
I like asking for the
All right. So now. All right. Yeah, so we're going to do numbers now. So we're going to complete the square. Ready? So this is just an example, and this will be an example that would be at like the Algebra 1 level. So we have x squared plus 14x minus 3 equals 10. All right? Currently, this is not a perfect square trinomial. All right? So, we're going to make it a perfect square trinomial. And the way that we do that is we're first going to get rid of that c value, right? The constant. So, the 3 needs to be brought over to the other side. So, I'm going to show my work this time. So, I'm bringing 3 over to the other side. I'm adding it over. So, now I can rewrite this. I'm going to have x squared plus 14x. Now, I'm going to leave a gap. I'm doing that on purpose because we're going to have another number in a few minutes. And then 10 plus 3 is what? 13. So see, this side, we're just going to be able to keep simplifying. We're not going to have something crazy. I know up here it looks all crazy. But we're going to be able to just keep adding or subtracting, and, you know, it's not bad. Now, there is a value missing for this to be a perfect square trinomial. So we need to figure out what goes there. Again, in order to figure out what goes there, that's where we have to do the b value divided by 2 and the squared. So it is 49. So what was your b value? 14. All right, so it's a 14. So we had 14 divided by 2 squared. 14 divided by 2 is 7. 7 squared is 49. So that's the value that we have to plug in here. So plus 49. And then you have to do the same thing to the other side to balance the equation. So we're also adding 49 over there. So now this is a balanced equation, and the left side is now a perfect square trinomial. So there is an extra step, because technically we have just completed the square. But we're always going to take this one step further and factor it. All right? So I use the word factor. We're not actually going to do the process of factoring. We're just following the same pattern I showed you up here. All right? So we're going to take the first term, which was x. What's the square root of x? What's the sign in the middle? Plus. What's the square root of 49? So And that's going to be the binomial that's equivalent to that perfect square trinomial. Again, if you were to actually factor this, you'd use that 14. You'd have to split it apart, factor by grouping, and you would get this as an answer. Again, I'm just showing you it based on a pattern because I'm not going into factoring right now. But again, it's being used, right, if you were to show your work. I'm not showing that process. Once we're done with the FSA and stuff, at the end of this year, after the geometry FSA, I'll go back and I'll refresh some algebra topics that you guys will need for your future classes, things like factoring and stuff like that. But I'm not going to touch factoring until then, all right? So, completing the square can be done just by a pattern. You don't have to actually do anything.
And you add the 13 point out.
So now, yeah, on the other side, you're going to add the 13 and the 49. So 13 plus 49 is... So now, we don't have to do anything else with this. If this was algebra, your directions would probably be to solve. All right? So if we were to actually solve, what you would have done next is you would have got rid of your square by square rooting both sides, and then you move the 7 over by subtracting, and you'd have a value for x. You'd actually have two values for x. All right? So again, we're not going that far with it. All right. So now, it'd be nice if that's where we could stop, but that was last year in Algebra 1. All right. So now, fast forward to this year. For this class, guys, listen. Don't stop paying attention now. This class, we have to do it with two terms. So not two different variables. So an x and a y.
Oh, you played.
So so we have x squared minus 6x plus y squared plus 8y plus 2 equals 10. Now, we're going to do the same thing as we did before, except we have both an x and a y value. So we're going to do this for both the x and the y separately. So it's, no. So this is the same thing. It's just you're doing the completing the square process twice in the same problem. All right? But you're doing it at the same time. So it really isn't even that much extra work. It's going to be the same number of steps total. All right? So on here, if we take a look at the equation that's over here, we have a constant. Again, you won't always be given a constant. But since we have a constant on the left side, we're going to move it over. So move the 2 over by subtracting it. So minus 2. Now, I'm going to rewrite this. I'm going to leave a blank as I do this, so pay attention to where I leave these. So I have an x squared minus 6x. And then I'm going to leave a blank here because we're going to have to complete the square for this part. But then we're also still going to have the plus y squared plus 8y. And then we're going to have another blank because we're going to complete the square for the y values. All right? Oh, I didn't put the plus on there. So again, we don't know what's going there yet. We have to figure that part out. On the other side, we have 10.
8.
Oh, sorry, 8. Thank you. I didn't do my subtraction. Thank you. Thank you. Good thing I wasn't recording or anything. All right. No, I am recording. I was joking.
I know.
So, yeah. All right. Anyway. Now, on here, whenever we end up adding over here, we have two numbers. Guess what we're going to have to do to those? Add them over here as well. So the same blanks that we have over here, we're going to have to add to this side. Now, we don't know what those are yet. We have to figure out what's going to complete the square. So we have to do what we did up here with our b value 2 separate times. Because we essentially have a b value for your x, and we have a b value for the y. So, question?
Is it 9 to 16?
It is 9 and 16. Yes, you're right. So, on here, how did you get those? So, what is the b value here? 6. And it's a negative 6, so it doesn't actually change that outcome because it always will be a positive number. All right? So, again, the b value is actually negative, but your value will always come back as a positive. So, when you go to do this value is 9. So that's what you're going to add in on this side. So we have x squared minus 6x plus 9. On the other side, we're going to use the 8. So we have 8 divided by 2 squared. 8 divided by 2 is 4, and 4 squared is 16. So that's what we're going to have to plug in for the other blank. So plus y squared plus 8y. Ladies, gentlemen, shh. Again, don't stop paying attention here. So we're adding the 16. So on the other side, we have 8. We're also adding the 9 that we added in. And we're adding the 16 to balance the equation. So now, we're almost done. On the left side of the equation, this is going to become...
Wait, so the 2 on the bottom is just always there no matter what? Okay, never mind.
Yep. So, we're going to change this left side of the equation to 2 different binomials that are being squared. So first for the x's. So for the x's...
Up a little bit.
Yep. So for the x's, what's the square root of x squared? What's the square root of 9?
3.
What's the sign in the middle? Minus. Right. Then, we still are going to have a plus sign in between. But then, for the y values, the square root of y squared is?
5.
The square root of 16 is?
4.
And the sign in the middle?
Plus.
On the other side, 8 plus 9 plus 16 is 33. Now, does that equation look familiar?
Yes, it does. Oh my god.
Now we have our equation of a circle. All right. So this is the equation of a circle. This is a useful format for us to find things like center point.
So we're
And-
completing the square to find a circle.
Yep.
Do that.
Yeah.
How? Why?
Yep. I could have phrased that better myself. We're completing the square to find a circle. Yep.
This works, and I love
So
it so
we
much.
have these 2 values would act as our center point, right? So if I asked, we could find the center of the circle, which is at positive 3, negative 4. And the radius would be the square root of that 33. That 33 is our r squared. So this is our standard form of the equation of a circle. Now, I didn't give you any directions on the second one because I didn't want to spoil where we're actually going with this. But what we did was we took an equation that was not very useful for us, but that equation is actually the equation of a circle, just in a different format. But it's not a very useful format. So what we did was we completed the square so that we were able to change it to the equation of a circle. All right?
That's fine. Question.
Yes.
I see why it works. But how does it? Or no, I see how it works, but why? Why is this a thing?
It's just called manipulating the numbers. I mean, it's math. We were taking an equation that will give us a circle. It'll give us a circle. Guys, again, we're taking an equation that will give us a circle if you graph it. But unless you're using some type of computer or graphing calculator, you won't be able to graph that based on that information. We're changing it into a format that we can graph by hand. So on Tuesday, we'll talk about actually graphing a circle on a graph using these different formulas that we've done now. Question. Yeah, pass the back there. All right. So now we're going to take a look at a couple of questions straight from your book. So if you want to flip in your book to page 397, you can. Now there is not a lot of room in your book to do these problems, so you might just want to do them on the same notes as well. But if you want to reference it, we're going to do A and C from the try these. Algebra?
Yeah.
It's algebra and geometry.
Yeah, I love algebra. I hate proofs and such.
Alright. So again, this is from page 397. Try these. A and C. Those are the two that we're going to do. Alright? Now, I'm also going to write the directions. Shh, guys. I'm going to write the directions down so that I have them written here. But the directions are find the center and radius of each circle. So, now that we know what we're actually doing, they are giving us equations. Shh, guys. They are giving us equations that are not in standard form of the equation of a circle. However, you'll notice on this first one is also not in the other format that we had to start off either. It's like halfway there, yeah. We have the x's, we don't have to do anything with the x's. The x's is fine. The x's, we have a binomial squared. So on this one, we only have to do the y values. So now we're only going to complete the square once for the y values, and we don't have to worry about doing the x's. All right? So same thing that we did before. So I'm going to move, or actually, is there any constant here to move over? No. So we don't even have to worry about the first step either. So we're going to rewrite this and leave that gap to figure out what do we have to add on here. So plus y squared minus 2y, and then we got to figure out what value do we have to add in. And again, whatever you add over there, you're going to have to add to this side as well. So what number do we actually have to add in? 1. How'd you get 1?
Divided by 2 and square root.
Yeah, we took the 2, divided by 2, and squared it, which gave us 1. That's where we got that number from. Yeah, we took that number into that math. All right? So now, this part doesn't change. The y values, again, square root of y squared is, square root of 1 is, sign from the middle, and 8 plus 1 is. So now, the question is, what is the center and what's the radius? So the center is no. 5 and 1. Remember, as we pull those out, the h and k values, we have to change the signs. The radius is 3 because we have to take the square root of that 9. So that's going to be 3. All right? How are we doing so far? Give me a thumbs up if you're good. Give me a thumbs down if you have no clue, or give me a in the middle if you're okay. You're almost there. That's pretty good. Yeah. Huh? Can somebody open it? You good? Yes. All right. All right, let's do one more example.
Slide up behind this. Is there a math problem?
I got you.
Is there a math problem? I heard math.
Someone mentioned the word math around this place last week.
Now,
I can smell math a mile away.
couple things. Shh, listen, real fast. So, couple things I want to mention before we do this next problem. All right, if you want to take a minute to try it on your own before I do it with you, that's fine. When we do these completing the square problems, most of the time for what we're doing in this class, they probably won't give you a constant on the left side. They'll probably already have the constant over on the right side. However, one thing that you probably will see on some problems, I haven't found a question in Springboard like this, but don't be surprised if you see it on like the FSA or on another worksheet that I give you. The equation that I gave you there is not really in the proper format to start off. Normally, your variables are written so that they're in descending order of their degrees and then alphabetically from there. So normally, you would have, like if you were given this equation, a lot of times it would be written as x squared plus y squared minus 8x minus 14y, right? Because that would be the proper form. They're giving it to you so it already has x and y separated. So just don't be surprised that if you had to first, before doing anything else, separate the x's to the far left, the y's to the middle, and then your constant on the other side of your equal sign. So again, you might have to move things around a little bit more than what we're currently doing. All right, on this problem, you guys want a minute to try it on your own?
Yes.
All right.
Wait.
What time is it? So, yeah, we have a few minutes, so go ahead, try it on your own. I'll start it in like 2 minutes. What did you get for your final answers?
I got 747 and a minute.
Correct.
Ah, see, I love this.
I can't see that. Yep, that's correct.
This is why I went to math theory last year during lunch when I got bored.
So did you do completing the square last year?
Yes, but it was a lot more annoying than this, and I hated it a lot.
Well,
But
did they make you factor?
I don't remember. I just don't remember. I know I didn't like squares, and I liked the quadratic formula.
Yeah. Well, and see, you can factor. You can use the quadratic formula. You don't have to do this the way that I'm showing it.
This way is good.
But when the whole purpose of this is to find a perfect square, you might as well use the property of a perfect square to go backwards instead of doing the extra work of factoring or the extra work of quadratic formula.
The main reason I didn't like it was because I was out the day that she taught it, and then the kids that caught me up didn't get it.
Yeah.
So I.
But see, a lot of teachers don't do it this way either. A lot of teachers just go back to factoring or go back to quadratic formula, and that's a whole lot of extra work that is not necessary.
It's just like if there's an easy way to do it, let us do it the easy way.
Yeah. All right. So I gave you guys 2 minutes. I'm gonna go through again. First step, I'm just rewriting the equation so that I have the spaces. So x squared minus 8x plus some unknown value. Tape, you said, is over here. Plus y squared minus 14y plus another unknown value equals 16. And again, you have to make sure you add those two values on to this side as well. Now notice, unlike my first few times going through this, I don't rewrite my equation a whole another time after this. I just go ahead and plug them in after I've done these blanks. So, for the first value, for the b value for the x's, what value do you end up plugging in here? 16, yeah. Again, if you were to show your work on that, you have had the negative 8, that's your b value, right? So, negative 8 divided by 2, and then squared, which gives you the 16. So again, oh, sorry, I went off the screen there. So again, like I said, negative 8 divided by 2, and then squared gives you 16. So that's what we plugged in. Again, you plug it in to both sides. Then you had the 14. The negative 14, that's our b value for the y's. So what do you get when you do negative 14 divided by 2 and squared?
49.
All right, so 49 is what you're plugging in on the other side. So now, once you do that, again, we're almost done with this problem. This side we're going to change back to binomials. So for the x's, we're going to have a binomial squared. And for the y's, we'll have a binomial squared. So, for the x's, x minus 4. Yeah, so we had square root of the first term, sine from the middle, square root of the last term. All right, on the next one, what do you get? Y minus 7. Square root of the first term, sine from the middle, square root of the last term. All right, and on the end, it's equal to what? 81. So now our center is what? 4, 7. And the radius, what's the radius? 9. So again, the way we got the center, again, we just point out the h and the k values. Again, they always come out as opposites. And then the radius, this is the radius squared, so you have to take the square root of 81 to get 9. Alright, your homework is very short, even though we have a 3-day weekend. Your homework is on page 400, and it's problems 10 through 14.
Why is this not 10 through 14? 5 questions. 400.
Alright?
But I can't find page 400.
It's the same page that your homework was on last night. It's just the back of it. It's the back of the page from last night.
Not that one. That was.
Alright, so I know there's not enough time for me to come around and check it, so I'll check off both assignments on Tuesday. Again, no school Monday, so I'll see you guys on Tuesday. Our quiz will be on Wednesday of next week. So Tuesday we'll go over both homework assignments. We'll do a little bit of graphing on a graphing of a circle on a coordinate plane, and then we'll have our quiz on Wednesday. All right.
See, this is happening.
Of the quiz, the quiz will be based off of both days, both what we did yesterday and today. All right. There will also be one graphing question, and we're going to do the graphing part on Tuesday.